Hello students, now in this session I will explain question number 2 of exercise 7.1 chapter cubes and cube root. Okay, so let's start with question number 2. Now in question number 2 we have find the smallest number by which each of the following number must be multiplied. Okay, so we have to find the smallest number, okay, that must be multiplied, okay, to make it a perfect square. Now it is quite sure that all the numbers which are given under question number 2 are not a perfect cube number. Okay, these are not a perfect cube, but we have to make it a perfect cube. And how we have to make it a perfect cube? By multiplying one of the smallest number. So how to get that smallest number? The first thing that you have to do is you have to first do the prime factorization of the required number. Now for now it is given 243. So let's do the prime factorization of 243. So it is not divisible by 2, but it is divisible by 3. 81. 3 27s are, 3 9s are, 3 3s are, 3 1s are. Okay. Now the next step is we have to write all the factors of 243. 1 2 3 4 5. 1 2 3 4 and 5. Okay. Now after you have written all the factors, now the next step you have to make a triplet of all the prime factors. That is, this number is in the triplet form, but this we cannot take as a triplet, isn't it? Because 1 3 is missing. Fine. So how many 3's are more required to make this a triplet form? Only 1 3, isn't it? That means we need one more 3 like this. That means if we multiply one more 3, then it will become a triplet, isn't it? So how many 3's more? Only 1 3. So if you multiply 3 on the right hand side, and the same application we have to do on the right hand side also. That means if we have to make this form a triplet form, we have to multiply 3. For that we have to also multiply 3 with this number also. So what is the smallest number? What is the smallest number then? The smallest number would be 3 only. So what is the sentence that we have to write? We have to write that here 3 cannot be grouped. 3 cannot be grouped into triplets. Okay, into triplet of equal factors. Okay, so to make this 243 a perfect cube number, we have to multiply 3 with this number. So what we have to write? Therefore, we will multiply 243 by 3 to make it a perfect cube. Okay, so what is the smallest number that we are multiplying with 243? It is 3. Okay, so this is the required solution of sum number 1 of question number 2. Now let's move on to sum number 2 of question number 2. So sum number 2 we have 256. Okay, sum number 2 we have 256. These are the sentences that we'll have to write again and again for this question number 2. Okay, so I have not rubbed it. So the first thing that you have to do, yes, we have to do the prime factorization of 256. That is, now this number is divisible by 2. 2 ones are 2, 128. Again it is divisible by 2. That will be 64. Again 64 is divisible by 2. The answer will come as 32. 32 is divisible by 2. Answer is 16. 2 8s are, 2 4s are, 2 2s are, and 2 1s are. Now what is the next step that we have to do? Yes, we have to write all the factors, students. That means 1 2 3 4 5 6 7 8 2s are there. 1 2 3 4 5 6 7 and 8. Now what is the next thing? Yes, we have to make it a triplet. So this 3 can be formed into triplet form. This can be also make it in a triplet form. But you see, if you consider the last two numbers, this last two numbers cannot be formed into a triplet form because 1 2 is missing, isn't it? 1 2 is missing. So this is not in the triplet form. So how many 2 is required to make this a triplet, a proper triplet form? That is 1 2, isn't it? So if you have to multiply 2 on the right hand side, the same application you have to do on the left hand side also. That means here 2 cannot be grouped into the triplet of equal factors. Hence, or you can write therefore, we will multiply this 256 by 2. Okay, 256 by 2 to make it a perfect cube. Okay, very, very easy. Okay, now let's move on to sum number 3. Sum number 3, we have 72. So the first thing that we'll do with 72 is to do the prime factorization of 72. So that is 236, 2 18, 2 9s, 3 3s, and 3 1s. So it's very simple. Now what is the next step? I said 72 and all the factors of 72. That is 2 into 2 into 2 into 3 into 3. Okay. So what is the next step that we'll do? We have to form the triplets, isn't it? So this is in the triplet form, but as you see, the last 2 digits cannot be formed in the triplet form, isn't it? So how many more 3s required to form it in the triplet? So that is only 1 3. So if on the right hand side we have to multiply 1 3, then the same application we have to do on the left hand side also. That means 72 need to be multiplied with 3 to make it a perfect cube. So what is the sentence that we have to write? Here 3 cannot be grouped. Here 3 cannot be grouped into triplets of equal factor. Okay, so therefore we will multiply what? 72 by 3 to make it a perfect cube. Okay, so we will multiply 72 by 3 to make it a perfect cube. Okay, so now let's move on to the last sum of this session, that is sum number 4 of question number 2. 675. So now again we have to do the same application, that is first we have to find the prime factors of all the 675. Number 675, that is it is divisible by 3. Yes, it is divisible by 3. 3 2s are 6, 3 25s are, again it is divisible by 3, 7 5 75, 3 25, 5 5s are, 5 1s are. So these are the required factors of 675. So we'll write all the factors of 675, students. That is 3 into 3 into 3 into 5 into 5. So it's quite clear, it's not a perfect cube. So next thing, we have to form a triplet. So 5 cannot be formed into triplet form. So how many 5 more required to make it a triplet? So that means we have to multiply one more 5, isn't it? So we have to multiply 1 more 5. So the same thing we have to do on the left hand side also. That is, the sentence would be, here 5 cannot be grouped into triplet of equal factors, isn't it? So what is the number that need to be multiplied with 675 to make it a perfect cube? So therefore we'll write, therefore we will multiply 675 by 5. Okay, so on the right hand side, how many 5s we are multiplying? Only 5. The same thing we have to do on the left hand side also. That is, 5 is the smallest number that need to be multiplied by 675 to make it a perfect cube. To make it a perfect cube. So this is the required solution of sum number 4 of question number 2. Okay, so that's it, students, and the last sum, that is sum number 5, do try it on yourself. Fine, thank you so much, God bless you all and take care.